Got 1/2 for number 4, part A.
I got 1.5.
What you got, 1.5?
Yes, sir. Well, -3 over -2.
What was the first answer?
So I simplified, but the answer I got was -3 over -2.
Oh, so -1.5. Okay. So let's move on. Anybody would like to pause there on number 4, gradient? By the way, what's the definition of gradient again? Anybody? I'm not moving forward unless I get a gradient definition, please. We are waiting someone for definition for gradient, which is a very important word in economics, in accounts, in world market, in science. Trust me, not to leave MATH115 and you don't know how to define gradient. Please don't do that. Do not leave 115 and you do not know how to define gradient. I'm talking from experience for university. Please, I'm stressing that. Being recorded and I'm pausing. I know the importance of defining what is gradient, how to understand what gradient means. We are waiting for a definition for gradient.
So rise over run?
Rise over run is not really a definition. Rise over run is like how to calculate it. But if you look at the rise over run, let's start with the rise over run. What is actually happening when you're doing a rise over run? What is going on there? Rise over run is not really the definition, but how can we extract a definition from that rise over run? You have more information there. There are more information. Anybody? We are waiting. And you know what I'm sensitizing, what I'm imagining face to face in the classroom and a question like that, and everybody just sit down there watching school. Very few people will be going in their notes. You know, studying is a technique, you know. Studying is a skill, studying is an activity. How many times we talked about the definition for gradient? Okay, I'm still waiting. I'm waiting. We are waiting. Rise over run. Yes, that's how to calculate it. Vertical change over horizontal change. How can we put that in a sentence? How can we put all of this in a sentence? From formula back to sentence, back to a statement. Gradient is the what?
The rate.
What is it?
The rate.
The rate of what? Yeah, continue. You're on the right track. Gradient is the rate.
The rate at which the vertical varies with respect to the horizontal variation.
Yeah, look, the definition right there staring at us. The definition staring at us right there. The rate at which the vertical varies with respect to the horizontal. In other words, let's expound on this a little bit. In other words, based on what we had said about gradient before, what can we add to that? I will give some help. In other words, when the what?
When it rising or falling, not that necessary.
When it rising or falling.
When
That's
the
what we
earth
say.
falls.
Okay, so here we go. Just a minute. Because the way you responded there, I am forced to go where we talked about it. Number 9, I think. Yes, number 9. Let's check it. Number 9. And I don't really, I understand that's what we, where is number 9? Number 9, number 9, number 9. Yeah, look at there. Let me copy it. And paste it there. So what I'm noticing now, well, I know probably have a lot to do, but studying is a technique. Studying is a technique. There's note taking, revise your notes. Gradient is the rate. Okay, so when you think of gradient, always think of a rate. A rate is like an activity, something happening whilst another thing happening. All right, when you think of rate, let's go in Google. That's one of the advantages of doing this online. You don't have those privileges in the classroom. Definition. What is the definition of a rate? A measure, a quantity, a typical one measured against another quantity. Highlight this. This has been recorded, so let me just put that there. So when you think of rate, something is happening. Whenever you hear the word rate, it's a measure, it's a number, yes, it's a quantity or frequency, all right? Typically, one measured, right, that quantity is measured against another. So there's an interplay of two variables whenever you hear the word rate. Okay, so if you have a number and you say that is the rate, that number represents the activity of two variables. All right, yeah, this has been recorded, so replay it. But take note of it whenever you hear the word rate, because you can hear the word rate in another course, not just mathematics. Because what mathematics does is to give you the numbers and you're applying it now to your economics, to your, every time you hear anything in economics and upon the rate of change, the rate, the transfer of money, rate, things happening in physics, the rate at which movement, time and speed, in medicine, rate of increase of with time, something happening against another, two variables. That is a very, very important word. Do not leave college algebra 1 without a firm definition of the word gradient. It's a rate. All right. And what does rate means? Here it is. Typically one measured against another quantity. So a gradient is the rate at which the y values, which is a dependent variable, vary with respect to the x, once against the other. Okay? In other words, when the x variable increases by 1, the y variable varies. It could be decrease or increase. When you interpret in gradient, the x always increasing by 1, exactly 1. But the y variable can do anything. It can go up, it can go down, any amount. So the y variable varies by that rate. Good. Negative, positive. Okay. Negative is a decrease and positive is an increase. Please do not leave college algebra 1 without a firm definition of gradient, because chances are you will come across it in another course. Very important word. That's how it's calculated. Rise over run. Two variables interplaying with each other. Vertical change, horizontal change. Y2 minus y1 over x2 minus x1. Calculate the gradient. So you just apply the formula. Based on what we just said, let me hide this interpretation. Can anybody, just about to end. Okay, we're just going to end with that last interpretation. Before we close, can anybody interpret that 5.5? What does that 5.5 mean? Anybody? What does 5.5 means based on what we just said? That's a rate. Anybody? 5.5? We got M to be 5.5. We got a rate of 5.5. Okay, so here we go. This means that each time the x value increases by exactly 1, I'll just stress that, and the word increase in bold, the y values increase because it's a positive by 5.5. In other words, with every unit, 1 change variation of the x values. What kind of variation? We're talking about an increase, always an increase of the x values by 1. There's a corresponding 5.5 variation, an increase also because it's positive with the y values. So